Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss iterative pre-order traversal of a binary tree in Java. So friends, in my previous tutorial we discussed what is a pre-order binary tree traversal. So in pre-order tree traversal, we perform the three steps for each and every node of a binary tree. That we first visit that particular node, and then we visit its left subtree, and then we visit its right subtree. And this we do for each and every node. So in my previous tutorial we discussed the recursive pre-order binary tree traversal, and in this tutorial we will discuss iterative pre-order binary tree traversal. We also discussed that we apply these three steps to each and every node of a binary tree, that we visit that particular node, and then we visit its left subtree, and then we visit its right subtree. So friends, in my previous tutorial we used the recursion in order to traverse the binary tree. Now in this tutorial, as we are not using the recursion and we are using the iterative way, therefore we need to use an additional data structure which could hold the information of the nodes. So friends, when we use recursion and we call the method recursively, so it internally used a stack. So in the iterative way we will use the stack data structure. So friends, below is the algorithm for iterative pre-order traversal of a binary tree. And as we are using the iterative version of this algorithm, we are creating a stack which could hold the additional information for us, so that when we backtrack to a particular node, we can fetch it from the stack easily. And we also know that stack is a LIFO data structure, which means the last in first out. So the node inserted last would be the first node to be removed. And if you want to know more about stack data structures, you can watch my previous tutorial. So in this tutorial, let's take this example that we want to traverse the nodes of this binary tree. So let's see the demonstration of this algorithm step by step. So basically when we execute this algorithm, we start with the root, and the first step we check is whether root is equal to null or not. So currently you see root is pointing to the node having data as 1, therefore it's not null. And then we'll create a stack which could hold the tree nodes for us. So here you can see we have created one stack. Now this stack will hold the tree nodes for us. So on the first step we'll simply push the root node. Moving ahead. So friend, as this is the iterative version of the algorithm, we are using a while loop and we are placing a condition that iterate till the stack is empty. So currently you can see stack is not empty because we have pushed one node. Therefore the condition in while block comes out to be true and while loop executes. So in this line, as we know that stack has only one element, so therefore this element will be popped out, and we'll assign this popped node to a temporary node. So it would look something like this. So first the node will be popped out. So as the 3 node with the data as 1 was popped out, now this temp will point to that particular node. Moving ahead. So friends, in pre-order tree traversal, we first process a node, and then we process its left subtree, and then we process its right subtree. So in the first step, we'll simply print this node. So the output would be 1. Moving ahead. So friends, we have processed this node, and now we will process its left subtree and then its right subtree. So in order to do that, we are first putting the right node on the stack, and then we are putting the left node on the stack, because when we pop it out, we'll first pop out the left node and then we'll pop out the right node. And in order to do that, we are first checking that whether temp right is equal to null or not. So currently temp right is not equal to null. Therefore we'll push the node having data as 3 on the stack. So you can see 3 is now on the stack. And then we'll check whether temp left is equal to null or not. So currently temp left is not equal to null. Therefore we'll push the node having data as 2 on the stack. So friends, as stack is a LIFO data structure, it means the node inserted last would be the first one to be removed. And we also know that in pre-order tree traversal, we first visit the node and then we visit the left subtree. So basically in order to traverse the left subtree first, we push the right node on the stack and then we push the left node. Therefore, when we pop it out, we'll pop out the node having data as 2. Now we'll again check in the while loop whether stack is empty or not. So currently stack is not empty. Therefore, condition in while loop comes out to be true. And then we'll simply pop an element from the stack and we'll assign it to the temporary node. So the node is popped out. So it means now temp will point to the node having data as 2. And in the next step we'll simply print the data for the temporary node. So 2 is printed and hence we have processed this node, and now we want to process its left subtree first and then its right subtree. So on the stack we'll first put the node which is pointed by temp right, and then we'll put the node which is pointed by temp left. We'll check whether temp right is equal to null or not. So currently temp right is pointing to the node having data as 5, therefore it's not null. Therefore we simply push the node having data as 5 on the stack. And then we'll check whether temp left is equal to null or not. So here you can see temp left is pointing to the node having data as 4. Therefore we'll push the node 4 on the stack. And then we'll again execute the while loop and we'll check whether stack is empty or not. So currently stack is not empty. Therefore the while loop executes. And now in the first step we'll simply pop an element which is on the top of the stack. So here we know that 4 is on the top of the stack, so it will be popped out, and now temp will point to the node 4. Moving ahead, and then we'll simply print the data associated with this node, which is 4, and then we'll simply check whether temp right is equal to null or not. So currently temp right is equal to null. Therefore the condition in if block comes out to be false. And then we'll check whether temp left is equal to null or not. So here you can see temp left is also equal to null. Therefore the condition in if block comes out to be false. And then again in while loop we'll check whether stack is empty or not. So currently you see stack has 2 nodes, therefore it's not empty. So the while loop executes. And the first step will simply pop the top element and will assign its value to the temporary node. So currently you see node having data as 5 is the top element. Therefore we'll pop it out, and now the temp will point to the node having data as 5. Moving ahead. Now we'll simply print the data associated with this temporary node, which is 5. Moving ahead. We check whether temp right is equal to null or not. So currently temp right is equal to null. Therefore the condition in if block comes out to be false. We then check whether temp left is equal to null or not. So here you can see temp left is also null. Therefore the condition in if block comes out to be false. And then we'll again execute the while loop with the condition that stack is empty or not. So currently stack has 1 node, therefore it's not empty. So in the first step we'll simply pop an element from the stack and we'll assign its value to the temporary node. So here you can see when we do stack.pop, the node 3 will pop out and then the temp will point to that particular node. So it would look something like this. So now temp is pointing to the node having data as 3. Moving ahead. Now we'll simply print the data associated with this temporary node. So the output we see 3, and then we check whether temp right is equal to null or not. So currently temp right is not equal to null. Therefore the condition in if block comes out to be true. So in the if block we simply push temp right, which is the node 7, on the stack. And then we'll check whether temp left is equal to null or not. So temp left is pointing to 6, which is not null. Therefore the condition in if block comes out to be true. And we'll simply push temp left on the stack, which is 6. And then in while loop we'll again check the condition whether stack is empty or not. So currently stack has 2 elements, therefore it's not empty. So in the first step, we'll simply pop an element from the stack. So the top element is a node having data as 6. So this node will be popped out and its value will be assigned to the temp. So currently temp is pointing to the node having data as 3. And after this step, temp will point to the node 6 because when we do stack.pop, 6 will be popped out. So it would look something like this. So now temp is pointing to 6. We'll simply print its data on the console, which is 6. And then we'll check whether temp right is equal to null or not. So currently temp right is pointing to null. Therefore the condition in if block comes out to be false. And then we'll check whether temp left is equal to null or not. So temp left is equal to null. Therefore the condition in if block comes out to be false. And then in while loop we'll again check whether stack is empty or not. So currently stack is not empty because there is one node. And in the first step we'll simply pop the element from the stack and then assign its value to temp. So when we pop an element from stack, we know that 7 will be popped out. So therefore temp will now point to 7. So it would look something like this. And then we'll simply print the data associated with this node on the console, which is 7. And then we'll check whether temp right is equal to null or not. So currently temp right is equal to null. Therefore condition in if block comes out to be false. And then we'll again check whether temp left is equal to null or not. So temp left is also equal to null. So therefore the condition in if block comes out to be false. And finally we'll check whether stack is empty or not. So currently you see, as we have processed all the nodes of a binary tree, so the stack is empty. Therefore the condition in while block comes out to be false. So friends, using a stack we saw how we can perform pre-order traversal of a binary tree. So here we discussed about the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we created one class by name binary tree and we implemented binary tree into it. Now this class has an instance variable of type tree node, which is the actual root of our binary tree. We also discussed about the recursive pre-order tree traversal. And in this tutorial we will see the iterative version of it. So therefore I'll just comment this code. And below I will create a method as public void preorder. And in this method we'll write a code which would perform the iterative preorder tree traversal. So in the first step we'll check whether root is equal to null or not. So if the root is equal to null, so it means there are no nodes into the binary tree. So therefore we'll simply return from the method. And in the first step we'll simply create a stack. So here we will import the stack from java.util package. And as we discussed in slide, we'll just push the root on the stack. And after that we'll provide a while loop. And inside this while loop we'll check whether stack is empty or not. So if the stack is not empty, then the while loop will be executed. And in the first step, we'll create a temporary node and we'll pop the element from the stack and we'll assign it to the temporary node. And as we have popped an element from the stack, we'll simply print its data on the console. And in the next step we'll check that whether temp right is equal to null or not. So if temp right is not equal to null, then we'll simply push temp right on the stack, and we will do this step for the temp left as well. So here if temp left is not equal to null, then we'll simply push temp left on the stack. So friend, this is the iterative version of pre-order tree traversal. Now let's test this working on the main method. So in the main method we have created this binary tree, and then we have called create binary tree. So it will create a binary tree with few nodes, which we discussed in our previous tutorial. And the last I will simply call the preorder method. And when I run this code, so you can see it printed 9243, and it printed the same what we discussed in our previous tutorials when we had called the recursive version of the preorder tree traversal. So friends, in this tutorial we discussed about the iterative version of preorder tree traversal. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.